Hello, class. It's me, your professor. I just wanted to give you a more hands-on demonstration on how to do the function syntax and templates I've created for this particular assignment. So just follow along, and then with the file handy, you should be able to answer all your questions with precision and ease. So there's a bunch of questions in this particular assignment that require some sort of function syntax or template, and by use of the function syntax or template, it just makes life a heck of a lot easier for you without having to do the straight up calculations yourself. So that's what I'm here for. So on the first question, now keep in mind all these questions have different values for you folks, so what you see on my screen is probably going to be different than what you have in Leo. So the first question was asking, what is the critical value of t for a 90% confidence interval with a degree of freedom, that's what that DF stands for, of 16, assuming a two-tailed test. Very easy to do. So if you just click on the highlighted yellow cell and look in the function box here, you'll see we're using the TINV or inverse T probability function. And all that is we just input our probability. So in this case, it was asking for 90%. So we subtract that from 1, we enter in 0.10 or 0.1. in our degrees of freedom. In this case, it was 16. Just click OK, and you get a value of a critical t value of 1.745, yada yada yada. One thing I wanted to show you is I included a t table to show you where these values come from. So if you scroll down the table to a degree of freedom of 16 and a probability of 0.90, in this case 1 minus, that is 0.1, you'll see the same exact value, 1.7459. So that's where those numbers come from. So for question 3, very similar. Just what you need to know is you have to get those degrees of freedom, which is n minus 1. So in this case, it's asking for a critical value for a 95% confidence interval based on a sample size of 18. Well, 18 minus 1 gives you 17. And what I did here, if you click again on the yellow box here, the function syntax shows up here. You can enter it in. So in this case, it's 95%, and 1 minus that is 0.05. The degrees of freedom, I gave it a cell reference, so you don't even have to do anything. All you need to do is put in whatever your sample size is for your problem. It'll calculate the degrees of freedom and then update the function syntax accordingly. Easy breezy. For question 5, now this is a little tricky. You have to do one minor computation before you can use the template here that I have on the right side of the screen. So it's asking, there's 163 randomly selected students, find the proportion planning to travel home for Thanksgiving, given that it's 80%. What's the standard deviation? So what you need to know, first off, the standard deviation of a sample is equivalent to the standard error of the population. We're calculating a confidence interval for proportion. So to do that, you need to just enter in your sample size here. And now your number of successes. Well, that's equal to your sample size times, and what it gives here, the proportion. So you just got to take that 163, multiply it by 80%, which gives you 130. You drop in your 130 here. Our confidence interval is 95%. And then lo and behold, we get our standard deviation, which is the same as the standard error for the population. So, and all that does is, if you click on this cell, it's just pointing to this value here. So the calculator makes it very easy. Just know you got to calculate that proportion first to get this number of successes. The next item, question 6, again, very easy using the template. It's just asking what the lower limit and upper limit. This confidence interval calculator here for proportion. All you got to do is put in your sample size, your number of successes, what your stated confidence level is, if it's 95, 90, 99, whatever, and it just does all the calculations for you. And you can see here within each cell where those come from. And so here's your lower limit and your upper limit. And again, this is just a direct cell reference to this cell over here. Question number 7, you don't need to do anything. It's the t-table. Okay? Just telling you. Questions 8, 9, and 10, you can bang these out all in one worksheet with this template. Here's the data you're provided. Okay, there's 7 cases, so you just plug in your numbers here. It'll calculate the mean and standard deviation for you, and then it will input those means and standard deviation over here. I even included, now you know it's 7, but you can just put a count reference here. Anytime, let me show you something. Anytime you want to know how many values are in an array, if you just go equal count and then select your data, hit enter, look, there's your 7. So quick and easy way to count your sample size. So question 8 is the critical t-value that's calculated for you. Again, it's using the TNIV function syntax. The margin of error, which in this case is the interval half width, okay, again, is just the t times the standard error, and you get that value here. And then for question 10, it was asking for the lower and upper limits. Again, those are provided as well with the calculator. So all you got to do is punch in your data and it'll do it all for you. The key part isn't just knowing what these component parts are, the critical t-value, the margin of error, the lower and upper limits, okay? Item number 11, we're almost done. Again, just you have to change this outlier because I believe it was like 130 or 135. You just change that last value, that's why it's highlighted green, and it'll run all the values for you here. I also included just kind of like the formula as well for the margin of error, because it's a little bit different using the calculator, but you can actually see where it also comes from computationally. And then the last bit of computation for items 13 and 15, again, in this particular item, all you have to do is plug in the mean, the standard deviation, the sample size. The calculator here is going to take all those values that I have punched in here and calculate the lower and upper limits. So for the other items in the assignment, it asks if the values are above 300, below 300. Just so you know, when you're given the confidence intervals, lower and upper limits, you know, that's saying that this is, if you were to redo this 100 times, 95% of the time, the value's going to, the population's going to, value's going to fall within this lower and upper limit. So if the value's outside the limits, you don't have any evidence to accept it, so you would reject them. If the value's within it, it's in it, so it needs to be accepted, just so FYI. So for question 15, I believe it's the same numbers, but the standard deviation is significantly higher, like 70, 75. You just change this and it'll rerun the analysis for you. Okay, that's it. I know it was a little long-winded, but hopefully that better explains the template file and the function syntax that you'll need to rock it out on this next assignment. So that's it. Any questions, just ask.